Okay, today's lesson is 10-6, the binomial theorem. It's a very short lesson just to make sure you know how to apply it and use it. And it's going to lead us into the next one where we're going to talk about binomial probability. So to start off with, this is another application of Pascal's triangle that you have seen before. And so what it is very, very useful for is it actually helps us determine the coefficients of an expanded binomial. Okay. These are the coefficients. This triangle, each row is the coefficients that you get when you expand this binomial. Remember, binomial is two terms being added together. Okay, but one of the things I actually want to point out to you is how you create this. If you have not figured out already, every row begins and ends with a 1. How do you get the ones in between? You start with the 1 at the very top, and then you combine the 2 to get the next one. So this would be 1 plus 2 is 3, 2 plus 1 is 3. Then to get to the next row, start with a 1, then you add the 1 and the 3, add the 3 and the 3, add the 3 and the 1, so forth and so on. So if I did this one, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5. Again, ending with a 1. So I'm going to real quickly do the 6th row. So that would start with a 1, 1 plus 5, 5 plus 10, 10 plus 10, 10 plus 5, and 5 plus 1, and then it ends with a 1. So that is our row. You can use this, as I said, to expand a binomial. So this is an example of them expanding a plus b to the 5th. I'm going to do c plus d to the 9th and tell you some things about it. It's all summarized at the end, so you don't need to really worry about writing it down right now. Okay, use Pascal's triangle. So I'm going to go to Pascal's triangle. You could go and continue to get rows 7, 8, and 9, or you could go look at Pascal's triangle and get the coefficients. And those are the numbers from the row. When we say the 9th row, y'all, that means that the second number is a 9, because technically that's row 0. A plus b to the 0 is 1, because anything to the 0 power is 1. So this would be row 0, row 1, row 2, so forth and so on. So this is row 9. Okay. Now, when you do that, you've got your coefficients. So the first one is the 1. The next coefficient is a 9. Then we have a 36, and then an 84, 126, 126, 84, 36, 9. It'll come out in a minute. And a 1, which I don't write the 1. Okay. Now, you go to the first term, okay, which is C, okay, and it's always going to start off with your with whatever the exponent is. So it's going to be C to the 9th, and then it goes down by 1 in each term. So C to the 8th, C to the 7th, C to the 6th, 5th, 4th, 3rd, 2nd, C to the 1st. That's what happens. I cut it off. Okay. And then when I do the D to the 0 is the first one. So the next term is D to the 1st, D to the 2nd, D to the 3rd, D to the 4th, D to the 5th, D to the 6th, D to the 7th, D to the 8th, and 1D to the 9th. Okay. And notice in this very simple, straightforward expansion, y'all, in every term, okay, the exponents of your variables all add up to whatever power you're raising it to. So that's 8 plus 1, 7 plus 2, 6 plus 3. Now that can change if that's not just C and D in the middle, and we're going to talk about that. Okay, so this is the binomial theorem. This is exactly what I just talked to you about. I already told you n choose 0, n choose 1, n choose 2. It is that formula, our combination formula. Okay, and I just wanted to see this, but I'm going to write this for you in a simpler way in just 1 second. But I want to do an example where we have coefficients that are not 1. Okay, again, whatever. So this is, let's expand 5a minus 4b to the 4th power. Okay, the coefficients, I need the 4th row of Pascal's triangle. Okay, or if you want to punch it in your calculator, remember the first one is C4 choose 0, which is 1. 4 choose 1 is going to be 4. 4 choose 2 is 6. 4 choose 3 is 4. And 4 choose 4 is 1. So those are my coefficients. And then what I would encourage you to do is I go write down parentheses to start off with. So I'm going to write a 1 parentheses to the fourth plus 4 parentheses to the third. So I have one set of parentheses at the beginning and at the end, both to the fourth power. And then I have my coefficients and 2 sets of parentheses every time. So 4, 2 sets of parentheses, plus 6, 2 sets of parentheses, plus 4, 2 sets of parentheses. Then if I started with a 4, then that's going to go 3, 2, 1, and then that becomes 0, which is why that's a 4. And then you go backwards 3, 2, 1. Every set of parentheses adds up to 4. Okay, now what's going to change is what goes in the first set of parentheses is my A. And this is like my A part. So I'm going to have 5A in the first set of every parentheses. I don't have anything in the last one because it's 5A to the 0. And then I'm going to have 4B in the second set of parentheses. And yes, it is minus 4B. And if you put that in there every time, it will take care of whether or not it's going to be positive or negative. Negative 4b to the first power means this whole term will be negative. Negative 4b to the second power means that whole term will be positive. And y'all, if you will put this step to begin with, then each term, ignoring the variables, you can put into your calculator 6, open parentheses, 5, close parentheses, raise it to the second, open parentheses, negative 4, close parentheses to the second. You will always get the right answer. When people don't put parentheses around those negative numbers, they mess things up. So this is our final answer, putting that in. You should pause and check and make sure that you can get those correct when you put it in your calculator. Okay, the last thing, I told you it was a short lesson on this one, is sometimes you just want to find a single term. Okay, so if you look back at this example here, let's say I wanted to know, this says find the 6th term of that expansion. Let's act like I want to find the 4th term. Well, if I want the 4th term, that is the first term, this is the second term, third term, 4th term, and 5th term. So really what you want to find out is you're really looking at the B at the second term. What is B raised to? Well, if it's the 4th term, then that means that B is raised to the 3rd power. So what I'm going to give you is kind of a simplified version of this right here and show you how you can use it. So if you think about our binomial expansion, all right, A plus B to the N, okay, then you know that the first part of it is NCR, and then we're going to have A to a power, just like we were doing up here, okay? The numbers in orange are the NCR, and then we have the first term to an exponent and the second term to an exponent. So I've seen it written like this, and some people think this is easier to remember, and they call this, and I didn't come up with this, so don't give me credit for it, the Cranberry Rule, because if you see RANBR, kind of looks like cranberry, okay? So whatever this is that you're looking for, because remember that was 4 choose 0, 4 choose 1, 4 choose 2, whatever your R is, that's the exponent of your B term. And then this is N minus R, because remember these two exponents will always add up to whatever N is. So look at this example. If I want the 6th term, okay, the 6th term is when R is equal to 5. We already figured that out just a second ago. So that means that I'm going to do what's my N in this problem? Okay, N is 8. So I'm going to have 8 to choose 5, parentheses, parentheses, and whatever number is here is going to go there. And then I'm going to put this term in here and that term in there. And you have to remember the negative sign. So that's going to be 2C. That's going to be negative 3D. And calculate each one. 8C5 56. 2c to the third is 8c to the third because you have to distribute the exponent over both factors inside. Negative 3 to the fifth is negative 243, and then d to the fifth. So when you multiply that all out, and again, you can put it in your calculator, that's what you get for an answer. Very straightforward. Use those parentheses, put it in your calculator and practice, and I know you'll think it's easy. But if you have any questions, don't hesitate to email me or set up a Google Meet. Thank you so much, and y'all have a great day.